The next part I'll be working on is the propeller for the main rotor blade. It is obviously it's a true 3D profile, flat on the bottom, and I've never done any machining like this before. My CAM program has a couple of routines to do this, but the one I've chosen they call parallel finishing, and this is the toolpath it's generating, which is incredibly dense. In fact, you really can't even see what it's doing here, but the only thing I wanted to show you is that there's a lot of machining, because what it's going to do, I'm using a 1/8 inch ball end mill, and it's going to run parallel to the blade on the outer edge, and then I've got it set to do a step over of 7/1000ths of an inch and come back and do it again, and of course it will adjust its Z level as the blade is coming up and going back down again. So I remove the first pass that way, moving in very small 7/1000th increments all the way across, and then it'll drop down to a lower Z level and repeat the process until it gets the shape I'm looking for here. And then when it's after it's been machined, the yellow is indicating the piece of stock that I'm cutting this from. And then when it's finished, I'll just do a profiling pass around here, to cut it loose, and of course I'll drill this mounting hole. So let's get down to the workshop and see how to make this. I'm set up now to cut the main rotor blade. What I've done, the trick of course is how do you hold the stock down, since you have to mill every part of it. So what I've done is I've just used contact cement. It's the same kind of contact cement you would use to to hold Formica down, if you were working with that. What I found is that not only does it hold it down, but it's very easy later with a heat gun to remove the part from the waste piece I've got below it. So we're all set up. I've got an 1/8 inch ball end mill in here. Rather than using any coolant, because I don't want to mess with the contact cement, I'm just going to blow a very light stream of air onto the bit as this is running. That's just to keep the chips cleared away so that we're not constantly recutting the same chips. I guess that's about it. I think I mentioned before that this process, because we're removing so little material on each pass, it takes almost 5 hours to mill the profile here. So I'll show you as it starts up, and then I'll switch to a time lapse. I just turned the compressor on, and you can see that it's just keeping the chips out of the way. Anyway, this process will go back and forth. I don't know, it's over 3,000 lines of G code, so it's quite a bit of movement. And as when it finishes this pass, it's gonna reset and come 7/1000ths forward toward us, and make the same pass again. So, moving in 7/1000ths increments across the whole part, and that's just at the top Z level, and it's got to go back drop down further in Z, and do it again. That's why it takes so long. But the results are nice. And there goes the compressor. Well, anyway, that gives you an idea of how this looks in real time. I'm now going to switch over, set this thing up for time lapse, so you can see the part forming that way. Wouldn't it be nice if the milling machine could actually run at those speeds? Anyway, the 3D profile has been completed, and I've drilled a hole here for the propeller to mount to the main rotor assembly. And now I'm just doing a profiling operation to cut the propeller loose from the rest of the waste stock. The incredibly slow feed rate is probably overly cautious, but again, because the part is only held down with contact cement, I just don't want to take any chances now after spending 5 hours getting to this point. So I'll make a nice slow pass around here, profile it, and then we'll move over to the vise with the heat gun and remove this and see what it looks like. Alright, the part has been profiled now, so what I'm going to try to do is remove the outer piece, the waste part, and just leave the blade attached to the base here. And the reason I do that is because it's much easier to sand this piece if you have something larger to hold on to as you're sanding it. So this is a professional heat gun. It gets pretty hot. It doesn't take much. You just have to be patient. That's exactly what I was looking for. So this is hot now, but all that's left here is the blade, the propeller. And as soon as this cools down, I'll move over to where I'm going to be sanding it, and I'll show you what happens next. Alright, so here's the propeller that we just finished machining, and You know, it's not perfect. It's, you know, it certainly has some rough spots on it. And, you know, those could be eliminated or even minimized further by changing the step over from 7 thousandths, you know, down to a much smaller number. But then, you know, the processing time, you know, would go up drastically if I did that. So I find that this is a decent compromise. And I sand it, you know, I start off with, actually with, you know, some emery paper, which, I don't know what the grit is on this, but that'll do a good job on it. And I just wanted to show you that, I hope you can see that, but this is the first one that I did, and you can get a beautiful finish on this, but this did take me about an hour of sanding and then polishing to get it to look like this. So, you know, that's what I will do with this one, and it's just a matter of, you know, working at it. And you can see that by, you know, leaving it attached to the waist piece here, you know, it gives me something to hold on to as I'm doing this, because, you know, without it, this piece would just be flying all over the place. So anyway, that's what I'll be doing for the next hour or so. You know, and then I'll progress through finer and finer sandpaper all the way up to like 12,000 grit. And then after that, I found this this polish. If you can see that, this is a 1 micron polish that I found on McMaster Car online. It works great on aluminum, because even when you sand it all the way down, even to 12,000, it still has what looks like a matte finish. But as soon as you hit it with the polish, the shine like this comes out. So I'm not going to make you watch all of that, but you just have to be patient and work your way up progressively through the grits, not skipping any on the way. And although I use the first couple of rough grits dry, the rest of the sanding I do, I will be using it wet. I just use water as my wetting agent, but I find that works a lot better than working dry on aluminum.